very good morning to our ladies and gentlemen, and a warm welcome to the third International Conference in Data Science organized by the Center for Data Science and the Department of Statistics, University of Colombo, in collaboration with the University Malaya. To start with our agenda this morning, ladies and gentlemen, it is with great pleasure that we invite our distinguished guests to join the traditional lighting of our lamp to symbolize illumination, knowledge, and collaboration. Let me have the honors inviting the Vice Chancellor of the University of Colombo, Professor Indika Mahesh Karunatilaka, the Dean of the Faculty of Science, Senior Professor Cha Upulsonadara, Head of the Department of Statistics and Director of the Center for Data Science, Dr. Dilshani Tisera, Director of the University of Colombo School of Computing, Dr. Ajanta Tukurala, Chair of the Department of Statistics, Professor Chandima Tilakaratna, Co-Chair of the International Conference of Data Science 2025, Dr. Kang Shang Fei.
The Co-Chair of ICDS 2025, Dr. Gayan Darbaratnan, the Co-Secretary of ICDS 2025, Dr. Deshani Vikramarachi and Ms. Shanti Saubhagya, the former Director of the Center for Data Science and Board Representative from the Center for Data Science, Dr. Samira Viswakula, Founding Director of the Center for Data Science, Dr. Rasika Jayathilaka. Our keynote speakers, Professor Hiroshi Mamitsuka and Dr. Cho Shiani, a representative from our knowledge partner Octave, John Keels Holdings, a representative from our silver partner, Creative Software, and representing the presenters, Ms. Kavisha Vidushini.
We also have the honor of inviting representing the Board of Management, Dr. Shamak Natteguru, to also to join with the prestigious lighting of the oil lamp as we commence the proceedings of ICDS 2025. Inviting the former head of the Department of Statistics, Dr. Rushan Abhimanavapan, also to join with the lighting of the oil lamp. Ladies and gentlemen, with that, we're now witnessing the arrival of our distinguished guests to this whole premises as we are on the verge of commencing the International Conference of Data Science 2025. Ladies and gentlemen, distinguished guests and esteemed participants, a very good morning to all. It is our great pleasure to welcome you all to the 3rd International Conference in Data Science 2025, organized by the Center for Data Science of the University of Colombo and the Department of Statistics, University of Colombo, in collaboration with the University Malaya Center for Data Analytics.
To commence today's proceedings, we now invite you all to rise for the national anthem.
Thank you, and please take your seats. In the words of Satya Nadella, AI is a defining technology of our time. And today we stand at the frontier of a new chapter, where intelligent agents are beginning to make decisions, collaborate with humans, and shape the systems that drives our world. It is with this exciting landscape that we gather here to explore the remarkable possibilities of autonomous AI. Ishakya?
Yes, Vinuk. This year, we meet at a pivotal pivotal moment in the evolution of data science. The theme of ICDS 2025, Autonomous AI Agents, Redefining Decision-Making in a Data-Driven World, reflects the profound transformation taking place as AI systems gain the ability not only to analyze data, but also to reason, adapt, and act with increasing independence. This conference stands as a platform to examine how these technologies are reshaping industries, influencing decision-making, and challenging us to ensure their development remains transparent, ethical, and trustworthy.
Well, while we reflect on
every day, billions of decisions shape our future faster, harder, more complex. A new intelligence is rising, autonomous AI agents. From our first milestones to expanding horizons, we've built a community pushing the boundaries of intelligent systems. Today, autonomous agents are driving breakthroughs in real-time decision intelligence. Explore the science, systems, and ethics shaping the next era of intelligent autonomy. Hear from global leaders advancing the future of autonomous intelligence. Witness innovation. Engage with ideas. Shape the future with us. The Department of Statistics of the University of Colombo and the Center for Data Science, along with the University Malaya Center for Analytics, bring you
Now, to officially begin ICDS 2025, I invite the conference co-chair, senior lecturer at the Department of Statistics, University of Colombo, Dr. Gayan Dharmaratnam, up on stage to deliver the welcome address. Sir, over to you.
Very good morning to all. It's my great pleasure to welcome you all to the International Conference in Data Science, ICDS 2025, held under the theme, Autonomous AI Agents, Redefining Decision-Making in a Data-Driven World. This conference is organized by the Center for Data Science, University of Colombo, in collaboration with the Department of Statistics, Faculty of Science, University of Colombo, and the Center for Analytics, University of Malaya, Malaysia. Before I speak about the importance of organizing this conference, let me first acknowledge the presence of several distinguished guests. It's my great honor to recognize the Vice Chancellor of the University of Colombo, Professor the Registrar of the University of Colombo, Ms. Cassius Perra, the Bursar of the University of Colombo, Ms. J.T.L. Dharmasena, Dean of the Faculty of Science, Senior Professor Kusonagara, two keynote speakers of the conference, Professor Hiroshi Mamitsuka and Dr. Soshia Ni, and the co-chair of this conference from the University of Malaya, Dr. Kang Chong Fei. I would also like to extend a warm welcome to the Director of the University of Colombo School of Computing, Dr. Ajanta Korala, the Senior Assistant Registrar of the Faculty of Science, Mr. K. Tharmint, the Deputy Bursar of the Faculty of Science, Mrs. R.A.V.S. Perra, the Acting Librarian of the University of Colombo, Dr. P.K.S. Manatunga, the Deputy Librarian of the University of Colombo, Ms. Sajivani D. Somaratna, the representatives from the sponsoring organization of this conference, Creative Software, and the Octave John Keys groups, the head of the Department of Statistics, and the Director of the Center for Data Science, Dr. Dilshani Teixeira, and the board members of the Center for Data Science, all the Department of Statistics staff members, and all the other distinguished guests and the authors participating in this conference. Now let me talk a little bit about the importance of organizing this conference. Today we all know the world is changing very fast. Therefore we now have more data than ever before and new tools to understand the available data. Autonomous AI agents are an important part of this change. They can learn, plan, and make decisions by themselves. They help us solve problems in many areas. However, they also bring new challenges. We need to make sure these systems are safe, fair, and trustworthy. It is important that we use them in a responsible and careful manner. This conference gives us a wonderful opportunity to share ideas, learn from each other, and discuss both opportunities and challenges we face when it comes to the application of AI tools in real-world scenarios. During this inauguration ceremony and the follow-up technical sessions, we will listen to inspiring keynote speeches from our distinguished speakers, hear interesting research findings, and join meaningful discussions. This will give us a chance to explore new research, exchange knowledge, and hopefully start new collaborations. I encourage you to participate actively, ask questions, and connect with others. Finally, I hope you will enjoy these sessions, meet new people, and leave with fresh ideas and inspiration. Thank you once again for joining us, and I wish you all a productive and enjoyable conference. Thank you very much.
Thank you very much, sir, for your warm words of welcome. Ladies and gentlemen, the Center for Data Science is proud to have been collaborating with the University in Malaya for this third International Conference of Data Science, exploring new boundaries and bringing new opportunities to our students as well as to the academia and the industry through this International Conference of Data Science. So we are delighted to have our esteemed conference co-chair, Dr. Kang Chuang Feng, the Associate Professor at the University of Malaya. Sir, we kindly invite you to address this gathering.
Good morning, distinguished guests, Vice Chancellor, Professor Corona Dilakar, the Dean of the Faculty of Science, Professor Sonadara, the head of the department, Professor Teixeira, and also, of course, my colleague, the co-chair, Dr. Gayan. So it's a pleasure to be coming to Sri Lanka for the second time. All right, so Ayubowan. Well, that's the first Sri Lankan word, Sinhalese word that I learned from my very long time friend, Dr. Rushan. very long time ago, and we have kept the friendship going for so many years. All right, so it's a pleasure to be back here, and we are very happy to be invited to co-organize this event. So basically, the university's Malaya Center for Data Analytics is a research entity, right, that is trying to bring researchers who are interested in the field of data science and machine learning together. And I think this is a very wonderful opportunity for members in our center to link up with other universities in the region, all right, to explore opportunities, right? And in fact, I think this conference is a great platform for our students to present their work. In fact, we have a few of our students who came all the way from Malaysia to enjoy the conference, and also, of course, to enjoy your hospitality, which is the most important thing, right? Sri Lanka, we're famous for that. Okay. So I think without further ado, I think let's get the conference going. And final thing I want to say is, I think maybe some of you are aware of the word serendipity. So that comes from Sri Lanka. Okay. So you know, it's wonderful. It's an opportunity where good things happen by meeting people that we have not thought of meeting before. And I think it's very wonderful that serendipity happens in Sri Lanka. Okay. Thank you, everyone.
Thank you, sir, for your valuable message. Now, we kindly invite you to receive a token of appreciation. To present the token of appreciation, I kindly invite Dr. Rasika Jayatilaka, Senior Lecturer at the Department of Statistics and Chair of the Review Committee of ICDS 2025 on stage. Thank you, sir, and thank you, madam. The Department of Statistics at the University of Colombo, established formally in 2001, holds the distinction of being the first of its kind within a Sri Lankan university's Faculty of Science. With a legacy of excellence in teaching, research, and consulting, it has fostered a close-knit, supportive community that nurtures both academic and professional growth. It is also home to the Center for Data Science, established as the Research and Development Unit of the Department of Statistics, which is now close to celebrating its 10-year anniversary. We now call upon Dr. Dirshani Tissera, the Director of the Center for Data Science and Head of the Department of Statistics, to address the gathering. Madam, over to you.
A very good morning to all of you. Professor Indika Mahesh Karanatilaka, Vice Chancellor of the University of Colombo, Senior Professor Chair Pulson Nadra, Dean of the Faculty of Science, Dr. So Hye Ni and Professor Hiroshi Mamitsuka, keynote speakers of ICDS 2025. I'm really sorry if I mispronounce your names. Dr. Dr. Ajanta Korala, Director, University of Colombo, School of Computing, invitees, distinguished guests, ladies and gentlemen. It is my great honor and privilege as both the head of the Department of Statistics and the Director of the Center for Data Science to address you on this significant occasion, the inauguration of the International Conference in Data Science 2025. Organized by the Center for Data Science, jointly with the Department of Statistics, University of Colombo and the University Malaya Center for Data Analytics. Today marks a moment of pride and celebration, not only for our department and institution, but for the entire community of data science practitioners, researchers and innovators who have gathered here from around the world. This year's conference is a milestone in many ways. We are organizing this event for the third time, and the theme for ICDS 2025 is Autonomous AI Agents, Redefining Decision Making in a Data-Driven World, highlighting transformative direction of modern data science. What makes ICDS 2025 even more special is that for the first time we are hosting the event in collaboration with University Malaya, Malaysia. This partnership reflects our shared vision to cultivate a strong and vibrant data science ecosystem across institutions, borders, and disciplines. Their contributions have enriched the conference tremendously, and we look forward to many more collaborations in the years ahead. This conference also serves as a key event in the dual celebration of our Department of Statistics' 25th anniversary and the 10th anniversary of the Center for Data Science. These milestones reflect our long-standing commitment to excellence in teaching, research, and innovation. Over the years, we have cultivated a culture of inquiry and collaboration, nurtured generations of statisticians, and more recently, data scientists, and contributed significantly to advancements in both academia and industry. Today's event stands as a proud symbol of that journey. The International Conference on Data Science 2025 consists of a series of events aimed at providing a platform for experts and scholars to share and develop knowledge and skills in AI, most trending topic in the world today. Although today marks the official inauguration of ICDS 2025, the conference commenced last Saturday with a mini hackathon organized in collaborative with Octave, our knowledge partner. I must acknowledge that this event was enthusiastically co-organized by our dynamic student society, Ststistics. The hackathon attracted over 52 competing teams from universities across the island, and for the first time, 2 teams from University Malaya participated, further elevating the competitive spirit and energy of the event. I'm sure the participants are eager to witness the announcement of winners of the ICDS 2025 mini hackathon. A conference of this scale is result of the hard work and dedication of many individuals. I would like to extend my heartfelt appreciation and congratulations to all who worked tirelessly to bring this event to life. My sincere gratitude goes to the conference chairs, Dr. Gayan Dharmaratna and Dr. Kang Shangfei, the co-secretaries, Dr. Deshani Vikramarachi and Ms. Shantini Saubhagya, track chairs, coordinators, session chairs, the panel of reviewers, and the editorial team for their careful planning and commitment to academic quality. I also wish to thank our keynote speakers, guest speakers, resource persons for workshops, presenters, delegates and sponsors for their important contributions. I'm truly grateful to the Vice Chancellor of the University of Colombo, the Dean of the Faculty of Science, and my colleagues in the Department of Statistics for their continued support and encouragement. Their guidance has played a vital role in ensuring the success of ICDS 2025. As we begin this conference, I hope ICDS 2025 becomes a platform that encourages collaboration, inspires innovative thinking, and strengthens the bridge between research and real-world impact. May the conversation that takes place here guide us toward responsible, inclusive, and forward-looking applications of autonomous AI. I hope you will have an educational, productive, and enjoyable time at this very special conference. Thank you.
Thank you very much, ma'am. And now we invite you to please remain on stage to receive a token of appreciation. And let me invite Dr. Champa Magal, Senior Lecturer at the Department of Statistics and the Chair of the Editorial Committee of ICDS 2025 on stage to present the token of appreciation to the head of the Department of Statistics. Thank you very much, madam. The Faculty of Science, University of Colombo has been committed to producing adaptable and skilled citizens, fostering multidisciplinary knowledge and public-private collaboration to drive national development. It is a great pleasure that we now invite the Dean of the Faculty of Science, Senior Professor Charles Upul Sonandar, who has been the visionary leader guiding our faculty towards its many accomplishments today, to address this gathering.
Thank you. Good morning, everybody. Professor Indika Karnatilaka, Vice Chancellor, University of Colombo. Dr. Dilshani Tisera, Head Department of Statistics and Director, Center for Data Science. Conference co-chairs, foreign participants, keynote speakers, distinguished invitees, ladies and gentlemen. It's my pleasure and privilege to address you today as the Dean of the Faculty of Science of University of Colombo. So as you know, this is the third time we are organizing this conference on data science. The conference first organized in 2021, as mentioned earlier, by the Center for Data Science in collaboration with the Department of Statistics, especially to mark the 20th anniversary of the Department of Statistics. This is a very important milestone in our faculty history. And today I'm happy to note that third conference, University of Malaya, they are collaborating with us on this conference, which is a very positive event in our calendar now. So year 2021, this was a special year for all of us. That is because it marked the centenary of excellence in science education at the University of Colombo. So 100 years is a long time. So we have roots going back to the establishment of the Ceylon University College in 1921. And university played a pioneering role in shaping the modern university education in Sri Lanka, setting standards, especially for teaching and research. Faculty of Science came into the existence in 1942 and quickly grew into an important academic entity. By 1950s, University of Ceylon was already recognized as one of the leading institutions in the Commonwealth. So when you look at from 1916 to present day, many of our academics have contributed immensely to the expansion of the higher education, scientific research, and science education in general in the country. So today I am proud to say that Faculty of Science has become the most sought after science faculty in Sri Lanka. Thanks to the commitment and contributions of close to 120 academics we have, we now support more than 2,300 undergraduates, pursuing over 30 specialized degree programs. One is the data science, and we also support about 1,000 students enrolled in fee-living external degree programs, which is offered in 6 disciplines. Our postgraduate numbers have grown substantially. Now we are looking at reaching 500 students, over 500 students engaged in master's and doctoral research. So when you look at the years to come in the future, we are looking at expanding our postgraduate education, especially already master's in data science program is already in the pipeline. and we would be very happy to collaborate with the University of Malaya, and especially to start PhD and research programs, especially related to data science and any other science areas you like to collaborate. So, the demand for admission to the Faculty of Science is highly competitive, especially in physical and biological sciences. Students with highest research scores in the country choose our faculty for their higher education. Within the physical science stream, applied mathematics is a compulsory subject and it's a core requirement. So it is noteworthy to mention here that nearly 80% of the students, they select statistics as a subject in the first 2 years. So this shows actually the academic strength of the department and the rapidly growing industry demand for qualitative and data-driven skills. We are living in an era where the value of science, mathematics and analytical thinking is appreciated more than ever before. So, emerging interdisciplinary fields such as data science and artificial intelligence depends on integration of computing, mathematics and statistics. In this background, students with training in statistics and related disciplines are uniquely positioned to contribute to and to secure employment across a range of industries and research institutions locally and abroad. So we value the conference such as this, which plays a very vital role in strengthening this further. They create space for new ideas, foster collaboration across institutions, and spark conversation that open new opportunities in data science and AI. I'm coming from a background where we collaborate on large projects. So I have done, particle physics collaboration. Sometimes you have over 1,000 members collaborating on a single project. So the value of collaborations, actually I know the value of the collaboration. And when you look at science development today, if you want to do high-end work, you need to collaborate. You cannot work in isolation. So as the Dean of the Faculty of Science, I am honored to be part of this event. I take this opportunity to extend my thanks to all the presenters and their co-authors for sharing their valuable research, and to all the participants who have registered and supported this event. On behalf of the Faculty of Science, I offer my sincere appreciation to the organizing committee for their dedication and hard work in making this conference a success. Thank you, and I wish you all the very best.
Thank you, sir. We now kindly invite you to remain on stage to receive a token of appreciation. And to present the token of appreciation, I kindly invite the Co-Secretary of ICDS 2025, Dr. Deshani Vikramalakshi, up on stage. Thank you, sir, and thank you, madam. The University of Colombo has blossomed into a center of innovation and scholarly pursuit, solidifying its reputation as the center of academic brilliance and intellectual curiosity. Fostering a dynamic culture of research and inquiry, the University of Colombo has been instrumental in advancing its mission and elevating its global standing. Now, it is my great privilege to invite our esteemed Vice Chancellor, Professor Indika Mahesh Karunatilaka, on stage to share his thoughts and insights with us on this momentous occasion. Over to you, sir.
good morning to all of you. Senior Professor Upul Sonadara, the Dean of the Faculty of Science, University of Colombo. Professor Dilshani Tisera, the head of the department and also the director of the data science, University of Colombo. Dr. Ajanta Tukorala, the director of the University of Colombo School of Computing. Dr. All the other professors in the University of Colombo, and also Dr. Gayan Dharmaratna, the co-chair of the ICDS 2024, the professors, senior professors of the Faculty of Science and also University of Colombo School of Computing. I would like to thank all of you for your leadership, for making this very important, momentous conference a success. It's a huge achievement, and conducting an international conference for 3 consecutive years is a very important milestone. A conference will not be called an international conference without international resource persons and participants. I would like to extend a very warm welcome to all the international delegates and participants. Conference co-chair Associate Professor Kang Song Fei from University of Malaya, and all the delegates from the University of Malaya. Very warm welcome. Selamat datang ini konferensi ICDS Universitas Colombo. Professor Hiroshi from the University of Kyoto, very warm welcome to the University of Colombo. Arigatou gozaimasu. And also very warm welcome to the delegates from the University of Malaya. Selamat datang, terima kasih, xie to all of you. And the researchers from University of Colombo, the students, very happy to see you. The graduates of data science special degree and also the researchers, because you are the future who will be taking this very important field to the next level. We are living in a changing world. We are living in a data-driven world. About a century ago, at the beginning of 20th century, in 1990s, it would take about 100 years for the data to double. But in 1940s, the time period where the Faculty of Science started, it would take 25 years. In 1980s, it would take about 1 year for the data to double. 1990s, 1980s. Now, data is doubled, information is doubled within 12 hours. We are living in the era of information explosion. Every second, information is generated. The smartphones that you are having, the smartwatches you are having, generating data in every second. We are living in an era where the data is generated in an exponential rate. However, the data will not be meaningful if we don't use the data for decision making. The data-driven decision making. That is where the data science comes into play. How to make meaning of data. That is where the big data analytics comes into play. That is where the artificial intelligence comes into play. Where we think about machine learning, and we talk about deep learning and neural networks, because what we want is to make meaning of data through neural networks and decision making using the complex information that is available. The generative AI has taken it to a next level, making use of the vast amount of data that's available and developing new content, generating new content. So we are living in an exciting world. During this time period, there cannot be more appropriate field than data science to make meaning of it and also for us to move forward. University of Colombo has taken pioneering leadership when it comes to computing and data science in Sri Lanka. For many decades, for over 25 years, the University of Colombo has taken a pioneering leadership. The number one university in Sri Lanka, the number one science faculty in Sri Lanka, has appropriately taken the leadership, starting a special degree course program in data science. And our graduates are always in demand in Sri Lanka as well as world. So that means a bright future. But there are challenges as well. As the data is increasing exponentially, then there comes issues like the ethical use of data, the originality, the veracity of data. So these are the future challenges. And these challenges are going to be increased over time in the years to come. So I think this conference will play a huge role to discuss these issues and also to work out and plan a network how to move forward. Collaboration is very important for this journey. We can't do it alone. That's why we have our international partners and participants, with whom we'll be entering into memorandum of understanding to work together and move forward. Collaborative research, again, very important. There's a need for research in data science because for Sri Lanka it's a new area. That's why we have to move towards collaborative research. And you don't need to look any further than your own dean, who is the most cited research in the University of Colombo with over 80,000 citations, shows the value of collaborative research. So I believe this would be a valuable platform for collaborative research in data science, in statistics, in computing, for us to move forward. Once again, wishing your fruitful deliberations, networking during this conference, and wishing all the very best for all of you. Thank you.
Thank you very much, sir, for your words. And let me now invite the chairperson, the co-chair of ICDS 2025, Dr. Gandhar Maratne, to present a token of appreciation to our Vice Chancellor, sir, for raising today's occasion. With that, ladies and gentlemen, we will now be moving on with our very first keynote address of ICDS 2025. To introduce our very first keynote speaker, I now invite the Co-Secretary of ICDS 2025, Dr. Deshan Vikramaraji, on stage.
Good morning to all of you. It is my privilege to introduce the first keynote speaker for ICDS 2025, Professor Hiroshi Mamitsuka, Professor at the Bioinformatics Center of the Institute for Chemical Research at Kyoto University, Japan. Professor Mamitsuka started machine learning research in 1990s when he was working with NEC research laboratories in Japan. At that time, machine learning was a small but promising research community into which researchers with a variety of disciplines were gradually coming to satisfy their interest in realizing artificial intelligence. He developed new techniques in machine learning, motivated by a lot of real-world problems like telecom churn, campaign management, and web access pattern mining. Since then, he has been in the machine learning field although his applications have been shifted into more scientific areas, particularly in life or medical sciences, after he moved to the academia. His current research focus in machine learning is on graphs, high-dimensional data, such as tensors and integrative learning of different types of data. Ladies and gentlemen, please welcome Professor Hiroshi Mamitsuka to address the gathering.
Okay, good morning, everyone. Thank you, Deshani. Very nice introduction for me. I'm really happy to be here. And before that, what I have to say is, actually, I really appreciate faculties of this university running this nice conference and for having me as a speaker. I'm really, again, happy to be here to deliver my talk on my research. Okay, so let's start my speech. I mean, this talk is a little bit longer than other people's speech, so hopefully you are not so much, tired or, I mean, pretty much getting tired of my talk. So, okay, so anyway, today I'm going to talk about graph learning, which I've been working on more than 20 years. And then before that, I want to talk about myself, kind of self-introduction. And also, my talk about graph learning is more like a tutorial. I want to talk about kind of basic concepts, idea, and also typical approaches. Then I'd like to give you kind of an example of the work we have been done. This is more like we are doing more than kind of typical approaches. And then finally I will summarize. So first of all, this is kind of my background. So I started my work when I was working with a company. My research was totally about machine learning and also data mining. And the data was from kind of industry totally. So what I was doing was business data mining. Then I shifted to academia after having my PhD. Then basically I've been working on biological data. So machine learning and bioinformatics are my area and motivated by biological programs. then actually topics I can raise about my research can be separated into two areas. One is machine learning, the other is bioinformatics. And about machine learning, actually today is part of this side. So I'm talking about the work on graph learning, particularly kind of hypergraphs or tensors, and then also kind of data integration is another kind of topic of my research. Also in bioinformatics, my kind of interests are pretty diverse. I mean, I'm covering a lot of, maybe all areas of bioinformatics. And also, recently, I'm pretty much interested in more general scientific data, like chemo or materials informatics. So, but actually today, I'm not talking about this, and I'm talking about just machine learning side, and particularly graph learning. Then I noticed actually there are two keynote speeches in this conference, and the other one is, to my impression, a little bit more practical. So probably my talk is more kind of basics. So hopefully these two will be well balanced for the conference. So first of all, I'd like to briefly explain the kind of basic concepts of machine learning. And usually in machine learning, we have this type of table type or matrix type data. So we have examples here, like this is not working so well. So one side is examples, and the other side is actually the variables. So so one side is kind of examples, machine people say, and the other side is variables or features. So this type of table data is usual, kind of matrix data is usual machine learning data. Then, for example, one type of program setting is kind of supervised learning. So in this case, we have actually a feature called the label. In this case, for example, whether patient has kind of disease or not, this kind of label Y is given. So then what machine learning has to do is to estimate kind of function between X and Y. So X is input and Y is label. Okay, so this is a machine learning, supervised setting. And then in prediction, once we estimate F, we can use F to predict Y by using any arbitrary X. So that's a supervised learning setting. Okay. Then unsupervised one is somewhat easier. So we don't have Y, we can just have X. And then using X, the problem we do is like clustering or factorization. Okay, but actually we don't talk about this so much today about graph learning. Okay, so then what I want to emphasize is we have 4 key points in machine learning. So the first thing is, the first point is okay, so I don't know, in my computer the point is working, but kind of slightly has a little bit problem. Okay. Anyway, first point is we have to estimate function f. For example, in supervised learning, f is kind of relationship between x and y. So we have to estimate f. This is the first point. And the second point is to estimate f, we have the main objective function. For example, kind of the error between given y and to be estimated fx. So, for example, this is supervised learning setting. So anyway, we have the objective function, and this objective function to be optimized. So, but when you use training data for optimization, actually, if you don't think about any consideration, things happening will be overfitting to the given training data. So to avoid this, we have terms in objective function called regularization of terms. Okay, so this reason term is a kind of design of machine learning people to avoid overfitting. At the same time, thinking about the prior knowledge we can have in the certain application. Okay, so then finally, we have to optimize the object functions with regularization terms. So there are 4 points in machine learning, and actually machine learning is doing just these 4 points, and I'll show you these 4 points in graph learning. Okay. Then we are moving to graph. Okay, so we have a graph, for example. In this case, we have A nodes, and 2 nodes in A nodes can be connected by an edge. Constraint in graph is for each edge, we have only 2 nodes. Okay, so this is a graph. This is a really simple example. Then graph is equivalent to agency matrix. So agency matrix must be symmetric. So what I mean is, in agency matrix, for example, if node 1 and node 2 are connected, the value, non-zero value is given. If there are no connection, no edge between 2 nodes, actually we can assign 0. Okay. So by doing this, graph and the agency matrix are equivalent. Okay. So we can, a good thing is, we don't have to think about the graph, we can just think about agency matrix. Then, okay, so usual assumption behind graph in machine learning is, if 2 nodes are connected, these 2 nodes should be similar to each other. Okay, this is simple assumption. Edge connection means kind of similarity of 2 nodes. Okay, so by this similarity assumption, we can use graph for some application, and I'll show you these examples. And these examples, actually we have not only graph input, but also we have a vector input, like a matrix or table input. So then this graph, or this input, is called attribute graph. So in this case, for example, we have A nodes, like this way, and then for each node, we have a vector. Okay, so this means each node is an example. Okay, so each node is an example, and by graph, you can see how these examples are similar to each other. Sometimes, for example, node 1, example 1 and example 2 can be similar. Okay. Then, by using by using table, or vector input, you can check this in other way. Maybe the vector attached to node 1 and the vector attached to node 2 might be similar to each other, hopefully similar to each other, because these 2 nodes have edge between these 2. So this means these nodes should be similar by the graph input. Okay. So, and this input is called attribute graph, and this is a kind of typical input in machine learning and also in our world. For example, one example is social network. So you have a lot of different types of social networks, and then kind of users nodes here. For example, node 1, node 2, user 1, user 2, or something like that. Then they can be connected by social network. At the same time, they have, for example, demographic data. Then these demographic data should show some kind of similarity or other properties of these users, instances. Also, another example is, for example, gene-related network. gene networks. So sometimes gene networks made by graph as a graph or network. At the same time, they can be given, genes can be given as kind of biological properties, like, each gene has a kind of expression in the cell, or each gene has a kind of sequence information. And actually, this type of input can be a table input. Okay, so what I want to say here is attribute graph is a typical example in machine learning data. And then this data, we have two aspects. One is graph, the other is vector or table manner input. Okay, so that's what I'm saying. Then anyway, we are moving more onto graph. So then we can now think about one property of graph called smoothness. Okay, so we now think about vector z here, and vector z has binary values. Then these binary values mean, okay, so here we don't have to think about the meaning behind this binary vector. We can just have z, right, binary vector. Then we try to estimate this vector by using given graph, agency matrix. This means we want to have z, so that z is consistent with the given graph w. Okay, so then to solve this problem, we can think about, this is a kind of solution. It's called graph cut. So when we think about, we can have agency matrix, right? Then if agency matrix has a non-zero value, we have to think about it. But if the value is 0, we don't have to think about this this term. Okay, so yeah, here. So we can just think about W, agency matrix, and then if again agency matrix, if agency matrix is 1, we can think about this term. The difference of the values of z between two nodes. But if W is 0, we don't have to think about this. So this means we can just think about the graph when the graph has an edge between two nodes, for example, I and j. So if there is an edge, we can think about this. If there are no edges, we don't have to think about this. So this is a kind of solution to have z being smooth with the given graph, Wij here. Okay, so then maybe I should derive this more carefully, but honestly, there are not so much time, so I'm not giving you pretty suddenly this. But anyway, so this is a kind of solution, and then we can derive this to a more organized form, like this way. And just I'd like you to focus on the result. Okay, so the result is this last one, z and z, right? Z transpose. Z transpose at z. So this is pretty simple way. This form shows, if you want to have z consistent with given graph W, actually you can kind of, sandwich something there from graph by this z. Okay, so then this L is from this way. L is from V minus W. And okay, so if you again, if you want to have z, actually you can just minimize this term, z and z. Okay, so this is pretty simple and interesting result. And then actually this z and z is called graph regularization term, and showing kind of graph smoothness. So if Z is minimized, so this term, ZLZ, shows graph smoothness, okay? Then, yeah, I mean, I'd like to say something a little bit more about this term. So this is, I mean, this form is related with, or actually one part of, or one type of Rayleigh quotient. And Rayleigh quotient is, I mean, actually given in a lot of literature. So one is, for example, quantum physics. Actually, Schrödinger equation in quantum physics is exactly having this form. Okay, so solving this, I mean, using this term and solving this as minimization problem of this term is pretty common in a lot of science. And what I want to say is in graph learning, this is also used. Okay, so then, yes, so I'd like to show you a couple of examples of common approaches in graph learning. So one is actually supervised learning. In this case, we actually the problem or kind of solution is called label propagation. And the other example is unsupervised learning. In this case, the problem or solution is called graph partition. Okay, so first I'd like to show you kind of typical approach in graph learning, label propagation, and how label propagation can be solved. Okay, so label propagation is actually literally the same as what you can think. So we have nodes, and part of the nodes can be labeled, like in binary labels, like +1 or -1. Then these labels, actually here, for example, +1 is red and -1 is blue. Then these labels can be propagated over all nodes. And these propagation can be estimated by the connection of edges in the graph. So that's a problem of label propagation. And this problem can be formulated like this way. So one is, we can think about these labels can be smooth over graph. What I mean is, for example, you know, if this label, I mean, if this node is connected to this node, actually the label should be simply. So in other words, the label of a node should be affected by the labels of the surrounding nodes. Okay, so in this sense, the label should be smooth with the given graph. Okay, so but actually, by this idea, or this idea can be implemented by using the term I just introduced called graph smoothness. So the actually F is label. This label should be consistent with the given graph, and this is implemented by minimizing this term. Okay, so also actually F is estimation of label, and then Y is given label. So these two should be consistent. So the other thing we have to think is label consistency. So both graph smoothness and label consistency have to be realized. So this is the basic idea of label propagation. I mean, label propagation can be, you know, solved by implementing. These two should be minimized. So yeah, again, so graph smoothness here, label consistency here. So the formulation, actually you have to think as a problem is like, you know, this is label consistency. This is graph smoothness. So this should be minimized under the condition of this. Of course, this can be vice versa. I mean, we can switch these two. But anyway, so this is one way, right? Then we can estimate f to minimize this one. Actually, can be solved by really straightforward way. We can take the derivative of this and making this derivative to equal to 0 here. So we can have kind of analytical solution of f like this way. So this is pretty simple solution and pretty efficient solution. And the label propagation can be solved not by using any iteration or some kind of stuff. This is actually very straightforward solution. Then, okay, we can now think about 4 ML points, key ML points of the about this label propagation. So model F is just a binary. For example, in the case of binary labels, F is actually binary assignment vector. Okay? Then, kind of main object function is label consistency. Okay? This is error between label assignment label F and given label Y. And also we have a regularization term to avoid overfitting. Actually, these two can be switched, honestly. And then optimization is, as I showed you, this is the main object function, this is regularizer. Then we can have an analytical solution like this way. Okay, so this is one type of graph learning, particularly in the case of supervised learning in graph learning. Okay, so then, yeah, okay, I'll mention a little bit kind of a connection to the recent kind of machine learning situation. So, for example, kind of, the machine learning is in the era of deep learning, and the graph neural network is one approach, or maybe kind of generalization of deep learning. Then, in case of graph neural network, actually this idea of label propagation is kind of extended, not like linear fashion, but more complex function is used here. But the idea is pretty similar. So label propagation is, in some sense, kind of graph neural network. Okay, then, okay, so the other typical example of graph learning is graph partitioning. So actually, this is clustering nodes in the graph. So, for example, we can have input graph like this here. Then the question or the problem you want to address is to separate these nodes into, for example, two sets of nodes. So this means we have given graph, and then output is we want to have two subgraphs. So actually, for this purpose, there are a lot of ways. For example, this is one result, possible result. So this case, this edge, these two edges are eliminated. So this case, we can eliminate a lot of edges, and we can have result, two subgraphs. Then in this case, we can eliminate only this. Then we can have two graphs. So the question is, which one? Which partition is best for graph partitioning? Then we can again have, we can again use graph smoothness here also. Graph smoothness can be, this term can be minimized under the condition that class assignment vector should be proper. In other words, actually, kind of solution is resultant to graph should not be biased. actually partition C is really biased, right? So, but the partition we want to have is like A, and instead of using a lot of edges, eliminating edges, we can reduce the number of edges to be eliminated. Okay, so to solve this question, we can just minimize graph smoothness, and then under the condition that class assignment vector is unbiased. Okay, so this problem can be formulated like this way, and then yeah, I mean this case also we can take Lagrangian and taking the derivative of Lagrangian and making this equal to 0. Then we can have a solution just as eigenvalue problem. Honestly, this kind of regulation term can be more complex, and then this solution is usually called spectral clustering, which is kind of really basic graph partitioning method developed in the 21st century. Okay, so anyway, this is our typical approach in graph line. Then this case, okay, once again, we can think about whole heap ML points. So this case, again, kind of class assignment vector is a kind of model. And then main object function can be graph smoothness function. And then regression term can be given for Z. And then optimization is done like this way. Then solution is an eigenvalue problem. So this is also pretty straightforward. I think pretty simple. But these two, I mean, one is graph partitioning, the other is derivative progression typical approaches. Okay, so then we can move forward further. So I'd like to show you one, actually my own work, kind of going beyond the typical approaches. So this case, the setting is like this. So we have more than one graph as input. So, in derivative propagation, the assumption was we have only one graph, but now we have multiple graphs. So, for example, in the other application, we can think about, for example, gene networks. Maybe, as I mentioned, so genes can be characterized by a lot of ways. One is, for example, gene expression, other is gene sequences, or interactions between genes and proteins. These type of things can be networks for each. So we have multiple networks, and given multiple networks, we can think about derivative propagation. And this situation is similar in social networks. So we can have different types of social networks, like Facebook, Instagram. Actually, I'm not so familiar with this type of thing. But there are a lot of social networks, and maybe same person is using different social networks. So this case, one social network is one kind of unique aspect of the person. So we can collect different types of social networks together and estimate kind of labels of people by using different types of social networks. Anyway, so actually the assumption of this problem setting is like this way. So we have multiple graphs, and some graphs are useful, some graphs are not useful. Then we want to capture useful graphs. So that's our idea. Then, okay, so I showed you already derivative propagation formulation. So in the middle of this slide shows derivative propagation formulation. I showed you already. So this is graph smoothness term. This is label consistency. So we can take the balance between them. I mean, this should be minimized under this condition, or this should be minimized under this condition. Then kind of straightforward extension from here about multiple graphs is we can make, we can give kind of weight for each graph and sum up graph smoothness sum over all graphs. That's a pretty straightforward extension. Okay, so this can be like written like this way. Then what happens in this case is, the solution is really simple. So if you want to minimize here under this condition, actually the solution is only one graph is taken. Most smooth graph is taken and others are discarded. So this is not the situation we want to have. We want to have, I don't know how many, but for example, 10 graphs are given. Maybe 2, 3 are useful, and rest are not useful, some kind of situation. We are not trying to find the most smooth graph. So this is not the solution we want to have. Then to satisfy our kind of objective or the situation we want to have, what we did was we added this term, L2 no here, because regularization was too sparse. Regularization gave a too sparse solution, so we gave L2 no. So this is more like a so-called elastic net solution. So we added this, and then I'll show you what happens. Okay, so then the solution for this is, actually this is a kind of biconvex problem. So we estimate F, and also we have weight mu. So mu and F are estimated kind of alternating way. So this means we start with some initial values for mu and F. Then we optimize F, fixing mu, optimize mu, fixing F. We repeat this iteratively. Okay. Then actually I'll show you kind of the result or what we did for solving this alternating optimization procedure. So the first part is to optimize F, fixing mu. So this case, okay, so this is our object function. Then if you fix mu, this one is just a constant, so we can ignore this one. Then we can take the derivative regarding F and making this 0. Then we can derive kind of updating rule of F. And this is actually derivation is skipped here, but the resultant updating rule is this way. Okay, so this is pretty similar or almost the same as a case. We have only one graph. So in the case of single graph level propagation, the solution was here. This is an analytical solution. And this is not an analytical solution, but this step, the updating rule is pretty simple. Okay, so this is pretty simple solution. So we can take, you can adapt this idea, this updating rule. Then the other way around. So fixing F, we can optimize mu. So this case, you can easily see if you fix F. So this one should be constant, right? So this one should be constant. This can be ignored. Then the point is this term and the last term. So this term can be written like this way. So smoothness term can be written as 3 for simplicity. And then this term can be here. Then the condition is, of course, mu is weight, so summation of mu is 1. Then, smoothness term is then you can think about this optimization problem. Actually, this is equivalent to quadratic programming problem. But solving quadratic programming problem is time consuming. So we use actually so-called Kahn-Tucker KKT condition. So then I'll show you how this can be applied to our problem. So this is actually general KKT condition. So we want to minimize some function f. And then the conditions are, there are two other functions, other types of functions, g and h. G must be kind of positive, and h must be 0. Okay, so there are two conditions, and we want to minimize f. So this problem is like this way. This is not written here, but anyway, this is home. Then actually KKT conditions are 4 types, but the most important are the first two. So first one is stationary condition. So we can take the derivative of this formulation and making this equal to 0. Then other, pretty useful condition is complementary slackness. So this one must be positive. This one can be 0 for all k. Actually must be 0 for all k by using alpha. So this is pretty interesting condition. Then back to our problem. So formulation is like this way. And then, when you take the Lagrangian, considering the condition of our case, Lagrangian is like this way. This is actually f in the case of KKT condition, general KKT condition. And then this one is actually h, this one is g. We take negative, and by that this is always positive. Originally this must be negative, so actually, sorry, no positive here. So we to implement this, we do negative here. So this is g, and this is h. Okay. Then this is f. Then from stationary condition, we can take the derivative of this one and making this derivative to 0. So this means, this is quadratic term, and others are not quadratic. So only here is, only mu here is remain here, and these 3 terms are coming here. Okay, so then we can see how mu can be updated by using other values. Then actually useful one is this complementary slackness. So this one is from here, g in the general KKT condition. So these should be 0 for all cases. Then, sorry, this is too detailed, but hopefully you might be interested. I don't know. So anyway, so there are two resultant equation, right? Then you can check. The case, this can be positive. So when this is positive, actually mu must be positive. So this means this one, this must be 0. Okay. Then actually by doing this, we can see each case we can see this psi or mu, either of them can be 0. Then we can have this one. So mu can be derived by this way, and sometimes mu must be 0. So okay, so so what I want to say here is this is the kind of situation we will have. Originally, in the straightforward extension, only one graph is taken as non-zero, and all our graphs, I mean, weights over all graphs are zero. So only one graph was taken. And actually, this was not the situation we want to have. But in this case, I mean, some graphs can be non-zero, and the rest of the graphs are zero. So that's a situation we want to have. Then, using this, actually, we can have some small number of graphs have the non-zero weights, and the others have zero weights. Okay, so yes, another point is this is really quick solution. We can compute, this is from a graph smoothness term. So in some sense, once we can compute the graph smoothness term, we can see this value. And also, by checking this, we can say some graphs are not useful. I mean, their weights are zero. So what I want to say here is this is pretty, efficient optimization manner. Then we can solve the problem. I mean, kind of the setting we want to have eventually. Okay, so I show a kind of experimental result really briefly. Then comparing with other methods, our performance was better. I mean, by using kind of synthetic data, this second synthetic data is pretty typical and famous one. And then also other point I want to emphasize is by using real data, you can see the performance-wise our method is here comparable to others. But when we check what kind of graphs we took and then how they are useful, actually our way is pretty much useful than others. So that can be shown by real data. Okay, so thank you for listening. I'd like to summarize my talk. So this is a summary of the method kind of going beyond the typical approaches for new problem setting. So in this case, we have multiple graphs in level propagation setting. And then we showed kind of ideal solution, like some of the graphs are useful and the rest are not so useful. Okay, so then optimization method is very efficient and the weights can be in some sense sparse. Okay, so this is a kind of entire summary. After my own introduction, I showed kind of basic concepts, ideas, and typical approaches of graph learning, and also I showed our own work. I mean, the case of using multiple graphs. So here's the difference, and finally, I'd like to advertise my own textbook. Okay, thank you very much, very much. That's all. I don't know, if you want to have any questions, I'm happy to accept them, but I'm not sure how this should be. Probably in lunch or other times, if you have any. Okay, you can, yeah.
Can we apply this graph neural network with any transformer combining to many other transformers or self-supervised learning?
Yeah, actually today's talk is about general approach. So you can apply to any domain. I mean, what kind of domain? Sorry, this doesn't depend on what kind of domain you have. Yeah, this is pretty general approach. if you have any question or any comments, if you think of later, yeah, please let me know. Yeah. Once again, thank you for listening. Thank you very much. Yeah, sure.
Thank you, Professor, for that insightful keynote address. Now, we kindly invite you to remain on stage to accept the token of appreciation. And to present the token of appreciation, I would like to invite the chair of the Hackathon Organizing Committee, Dr. Samira Vispakula, up on stage. Thank you, sir. Ladies and gentlemen, now get ready to be swept into rhythm and color. Please enjoy a vibrant cultural performance where our very own dancers come together to mesmerize us all. Let's give a warm round of applause to the dancing circle of the University of Colombo.
and gentlemen, that was the dancing circle of the University of Colombo. Well, with that, we're now moving on with the most awaited moment, and that is for the awards ceremony of the Mini Hackathon 2025 held in collaboration with ICDS 2025. Shaka?
Yes, Binuk. Organized by the Stat Circle of the University of Colombo in collaboration with Octave, John Keel's Holdings, the Mini Hackathon 2025 is conducted as a part of the ICDS 2025. This initiative aims to address the growing need for skilled statisticians by providing a dynamic platform for emerging talent to strengthen their data analysis capabilities, sharpen their programming skills, and solve real-world challenges through data-driven approaches. More than just elevating the quality of statistical insight, the Mini Hackathon 2025 seeks to enhance public exposure to innovative and impactful data solutions.
Alright, so we had more than 50 teams joining from the universities, both state and private, across the country, all the way from the University of Ruhuna to the Central Highlands University of Peradeniya and all across the country. So out of those 52 teams, ladies and gentlemen, we had the initial screening round and we selected top 15 universities to take part in the final round. And the top 15 teams competing with each other, we have selected the top 5 teams, and we have had the final round of the competition in last Saturday, and today we have the top 5 teams joining with us today, and so they have not yet received the official results, so to hand over the results to us, may we kindly invite the chairperson of the Hackathon Organizing Committee, Dr. Samira Viswakula, on stage. So I have the honor saying. All right. Okay. So let's begin with the second runners-up. May I have the honor in inviting Mr. Sahan Pereira, Head of Talent and Employee Branding at Octave John Keel's Holdings, to please join on stage as the presentation party for the second runners-up. Well, the second runners-up of Mini Hackathon 2025 goes to the team Alpha X. The team Alpha X, if I'm correct, from the University of Caledonia.
congratulations once again to the second runners-up of the Mini Hackathon 2025, and thank you once again, Mr. Sahan Pereira. Now, it is time to reveal the first runners-up of the Mini Hackathon 2025. Without any further ado, let me now reveal the first runners-up. The first runners-up of the Mini Hackathon 2025 are Team Explorers. Congratulations on this accomplishment. In order to present the first runners-up with their gifts, I would like to invite Dr. Dilshani Tissera, the head of the Department of Statistics and Director of the Center for Data Science at the University of Colombo.
And also, ladies and gentlemen, the winners, that means the top 5 winners from the Mini Hackathon, will also be receiving a cash prize sponsored by Octave. So that has also been given to our teams. Thank you, madam, for joining on stage. Well, with that, ladies and gentlemen, we are about to award for the winners of Mini Hackathon 2025, the champions of Mini Hackathon 2025. To do the honors in presenting to the champions the trophy and the cash prize, I have the honor in inviting the Dean of the Faculty of Science, Senior Professor Cha Upul Sonadara. Sir, please join on stage as a presentation party. And yes, with more than 50 teams across the country, both state and private universities competing to be crowned today as the champions of Mini Hackathon, the winners of Mini Hackathon 2025. Ladies and gentlemen, the winners of the third Mini Hackathon organized by the Stats Circle in collaboration with the International Conference in Data Science goes to the team Bite Force from the University of Moratuwa. Join your hands once again for Team Bite Force from the University of Moratuwa. Thank you very much, sir, for joining on stage. So we could mention about our runner-up also, the Team Explorers. So they were also from the University of California. So I invite you all to join your hands once again for our runners-up, Explorers from the University of California. Apologies for mentioning that as well. Vishaka.
Yes, Binu. Now, it is time to also award the certificates for the third and fourth runners-up of the Mini Hackathon 2025. In order to present the third runners-up with their prizes, I would like to invite Mr. Susana Jayavira Patabandige, an AI and ML engineer at Octave John Keels Holdings, up on stage. The third runners-up of the Mini Hackathon 2025 are Team Untitled from the University of Malaya. Congratulations on this accomplishment.
So we would like to have one representative from the University of Malaya to come up on stage, if we can, to receive the... Yes, ladies and gentlemen, it is indeed a pleasure for us to have the true meaning of international mini hackathon, because we had two teams competing from the University of Malaya. So we are grateful for joining and be a part of this mini hackathon for the third consecutive year. So we invite you all to please join your hands once again for the third runners-up, Untitled, the team Untitled from the University of Malaya.
Thank you, Mr. Susara Jayavira. Last but not least, it is time to announce the fourth runners-up of the Mini Hackathon 2025. In order to award the fourth runners-up with their prizes, I would like to invite Dr. Samira Viswakula, the co-chair of the Mini Hackathon Committee at the ICDS 2025. The fourth runners-up of the Mini Hackathon 2025 are Team Insight AI from the University of Moratua. Congratulations on this accomplishment.
Well, once again, ladies and gentlemen, join your hands to all the top 5 teams for taking part in this mini hackathon competition, and to all our participants all across the country, to all our undergraduates from all states and private universities across the country for being a part of Mini Hackathon 2025. Well, we thank Dr. Samira Viswakula for joining on stage as a presentation party. Ladies and gentlemen, with that we wrap up the mini hackathon, and on behalf of the Stats Circle as well, I take this opportunity to thank our wonderful staff at the Department of Statistics, the hackathon chair, Dr. Samira Viswakula, and his team as well for being sheer support and strength for us to organize this mini hackathon. And once again, congratulations to all our participants, and we wish to see you in the upcoming conferences of the Department of Statistics as well. Vishaka?
Yes, Biruk. We are now ready for our second keynote address of today's event. And to introduce the keynote speaker, I would now like to invite the former director of the Center for Data Science and board representative from the Center for Data Science, Dr. Samira Viswakula, back on stage.
Good morning, everyone. It's my great pleasure to introduce our second keynote speaker of the day, Dr. So Sherni. Dr. So is a senior lecturer at the Faculty of Computer Science and Information Technology, University of Malaya. She leads the Human AI Lab, where her research focuses on applied artificial intelligence and machine learning in healthcare, particularly in maternal and fetal medicine. With her PhD from National University of Singapore and prior experience as a research scientist at A-Star, Singapore, Dr. So has published extensively on AI-driven medical diagnostics and biomedical engineering. She is also an active member of the Young Scientist Network, Academy of Science, Malaysia. Please join me in warmly welcoming Dr. So Sherni. Her topic today is AI in healthcare from bench to bedside, translating research into impact. Thank you.
Good morning, everyone. It's a great pleasure to be here with all of you to talk about something we feel very far last time, AI in healthcare. So also thanks for the introductions. I'm Sherni from the Department of Artificial Intelligence, Faculty of Computer Science, and also Information Technology, University Malaya. So just a little bit of myself. I'm actually a biomedical engineer from graduate in and after that, with my PhD, which is also focusing on studies the fetus growth restrictions pregnancies, which we use biomechanical analysis to analyze the placenta. But after that, in 2019, I ventured into AIs, where we use AIs, applied AIs to solve certain medical problems. And right now, I'm in Faculty of Computer Science as a senior lecturer, and my research interest is really more applied as compared to fundamentals, where we applied some of the machine learning methods and also deep learning methods to solve the AI problems in focusing on just healthcare. All right, just a few years back, many of us weren't even sure what AI really means. It felt like a big mystery and full of buzzwords and even a little bit of fear. But today, we move from unknown to known. AI is no longer just a concept on paper or an idea that's discussed in conference. It's helping doctors to read scan faster. For example, you can see from here, we can use like AI segmentation models to segment out the different regions in the brains and help to do decision making, which also can eventually predict risk before problem arise. With the generative AI that's introduced recently, it also helps to facilitate research cycles, increase efficiency, and etc. We are really starting to see the real impact, not just ideas. If you look at the chart on the left, it shows the FDA-approved medical device across the years. In the early 2000s, we hardly see the bars, as you can see from here, indicate that AIs in the healthcare was basically just a research basic experiment. But if you look at around what happened after 2015, the growth shoots up, right? The growth shoots up and reach a peak at around 2022. We are seeing more than 100 AI-enabled medical devices approved, and many of them are in radiology, some in cardiology, and etc. So what does this tell us? It tells us that AI is no longer just an interesting theoretical ideas, but it also have matured into real medical device that are being evaluated, regulated, and also approved for use in patients. Regulators are now more understand to create pathways for approval. That's a big shift, where we move from uncertainty to something that is more stable and trusted. If we look at the picture on the right, we look at another dimension, in which it shows how people in our regions are adopting AI in daily life. This data focus on Southeast Asia, countries such as Vietnam, Indonesia, and our neighbors. And we compare them with a few countries on the other parts. You can see that a significant proportion of peoples are already own AI-related technologies, and even a larger groups plans to adopt them. So the key questions now is no longer, should we bring AI to healthcare? The real question is, how do we do it responsibly, safely, and in a way that fits our healthcare system and for our patients? And that brings me to the work that we are doing in our own backyard. Because to answer these questions, not in theory, but in practice, we need local research, local data, and also local innovations. So now I would like to share how our labs is contributing to this journey and how the work that we are doing aims to bridge global advances with Malaysia health care needs. In today's talks, I will highlight two projects from our team. The first is our work on small for gestational age, which focus on small babies, a problem that is very close to my heart. In fact, I've been working on these projects since my postgraduate days, and it's continued to drive a big part of my research today. It's an area where AI has the potentials to make a real difference for mothers and babies, especially in our local context. The second project looks at the oral lesions detections, which is particularly exciting because we are starting to see a direct and tangible impacts, bringing AI tools closer to the real clinical needs. So the first project that we are talking about is small for gestational age. As we see over here is SGA. The definitions for SGAs refers to infants born with birth weight less than 10 centile. You can see the babies on the left, which is the SGA baby, is much more smaller and skinnier based on the normal babies. The reason is being because during pregnancy, the placenta, that's the only organ that's formed during pregnancy, is not receiving enough oxygen and nutrients. So that's why the babies are much more smaller and some of the organs are not developing well. As you can see on the prevalence of these SGA babies, 32.4 million SGA infants are born in low-middle income country. 17.5 of newborns in Malaysia are actually SGA. And in Sri Lanka it's slightly higher, which is around 20%. 76% of these 20% of SGA baby in Sri Lanka actually were confirmed to have fetal growth restrictions, in which the cause of the FGR is due to placenta insufficiency, as we mentioned just now, where the placenta do not function well, they don't give enough nutrients and oxygen to the babies. Even these SGA babies are survived up till born, they also have higher mortality, 5 to 10 times higher mortality, and lifelong morbidities. For example, they will have higher risk of getting cardiovascular disease, cerebral palsies, and neural maldevelopments. The reason is because during the pregnancy, some of the organs do not develop well. So at the end of the day, when they grow up, so they will have higher risk of getting all these diseases. The current detection tools for SGA right now is through ultrasound, where they measure the biometry. They first measure their head circumference, abdomen circumference, as well as femur length to gauge the size. But it will show that the error can up to 10 to 15%. And we are unable to differentiate between FGR, fetal growth restrictions, and also SGA. The second method that used to detect SGA is use Doppler velocimetry, where you measure the blood flow in the umbilical artery blood flow. So in the normal babies, you will see that the end diastolic blood flow is positive. If you have an absence or even reverse flow, okay, this indicates the babies have a risk of developing FGR. However, according to one portal study, they reported that only 46% of SGR has absent or reverse end diastolic blood flow. This means that if you use this method, more than 50% of the FGR is missed out during the pregnancy. So we look at the consequences of the FGR. The stillbirth, which is the fetus death, okay, before you're born, fetus death, is around 4 per 1,000 pregnancy for all. If you don't have fetal growth restrictions, it's slightly lower. But if the babies have a risk of developing FGR, the stillbirth can increase up to around 17 per 1,000 pregnancy. Let's say if we are able to detect them, right? Detect them and give proper clinical care. The stillbirth can reduce from around 17 goes to around 10. But if we left it untreated, we do not know that the babies is of FGR during pregnancy, the stillbirth increased to 20 per 1,000 birth. And the cost to handle small babies is also increased. A normal baby should have a birth weight more than 2,500. Okay, so if you look at if the birth weight is reduced, if it's less than 1,000 grams, the cost to handle all these babies is around 18,000 pounds, and it even increased twice if let's say the babies have less than 1,000 grams or even less than 500 grams. So the cost to handle all these babies in neonatal ICU is also increased, which impose burdens to the hospital. So the question that we asked last time when I did my studies was, can we use artificial intelligence to early detect FGR? The reason is being currently most of the FGR cases are detected in the 3rd trimester. Okay, in pregnancy we have 3 trimesters, 1 to 9 months. Most of the time it's around 3rd trimester that is being detected. We were thinking, can we push the detections earlier to 2nd trimester, right? Since AI, we are living in a world with a lot of electronics data, and AI has the ability to analyze the data faster and find the patterns. So what we do is we get all the maternal demographics, for example, like the age, hypertension, the risk factors, whether the mothers have diabetes, etc. And then we also get the measurements of the fetal size, Doppler blood flow in the 2nd trimester. We use all these data to train a machine learning models and to predict the outcome of the babies. Outcome meaning over here means it will predict what happened at birth, whether it is a normal baby or SGA, which is defined by the birth weight less than 10 centile. So what we're really doing is we are using the 2nd trimester data to train the models, and we predict what happened at birth. So we are forecasting what's happened. So this is the result that we obtained. So you can see from here that we train 3 simple machine learning models like random forest, SVM models, and also MLP, multi-layer perceptrons. And the blue color bars over here shows the clinical diagnosis, which is the current methods that the doctors use to detect FGR or SGA in the current clinical practice. You can see that if you look at the accuracy for the clinical practice is not very high. It's around just 61 or 62%. All of the machine learning models have slightly higher accuracy as compared to the clinical diagnosis. And something that is very surprising to us that we found that because normally the uterine RI and PI, which is the blood flow, where it's an index that measures the blood pulsatility, should be the most important features in detecting all these babies. Surprisingly, these 2 features are not the most important features that is being analyzed that show that has a highest importance score. Instead, we found that nuchal fold thickness. Okay, nuchal fold thickness is a cerebral fluids that behind your neck that the doctors measure to detect Down syndrome. That's the features where if your NF is more than 6 mm, then you have higher risk of becoming Down syndrome babies. But in this case, what we found that NF is the most important features in contributing for the SGA predictions. So what we did later on, we just went compare the nuchal fold thickness between among the 3 different classes, where we have the birth weight above 10 centile, the normal baby, the small baby, birth weight between 3rd and 10 centile, and the severely small babies, okay, birth weight less than the 3rd centile. We can see that the nuchal fold thickness is significantly smaller, 4.36 and 4.29 mm as compared to the normal babies, which has a 4.77 mm. So this is something that is surprising new. We don't really see that in the literatures, and these studies was just conducted in Singapore with 300 plus samples. So the next questions we ask is, after I move back to Malaysia, we ask whether the same scenarios or the same observations happen also in Malaysian populations. So what we do is we get a larger data set to check out whether it is true. And surprisingly, not surprisingly, so I think expectedly, so we can see that in Malaysia data set, we have around 5,000 plus data set with 700 SGA babies. And again, we see the same trend. We see that nuclear fold thickness is significantly smaller, 4.568, as compared to the normal babies, 4.862. Okay, in the Singapore data sets, this is where we do a prospective studies with the Singapore hospital. We do not see significant difference. We suspect it could be due to the low sample size in the SGA cases. And using the larger data set in the Malaysia data set, around 4,900 to train, we tested on 543 Malaysia data sets. You can see that the logistic regressions has the higher performance with 0.69 balance accuracy, Singapore with 0.74, which is also slightly better than the clinical diagnosis. So we just put that into a Redel map. We see that the most optimal models is the logistic regressions, highlighted by the red color line, with 0.75 AUROC for Malaysia and 0.79 for Singapore. So with that, we kind of conclude that nuclear fold is really smaller in the SGA babies, where we see in Malaysia and also Singapore data sets. Then the next thing happened was we kind of met up with an India collaborator, where we have a collaboration with Annie Matthew Memorial Association AMA centers, in which that they have the third trimester data. They do not have second trimester data, so we collaborate with them to see how our third trimester data can be used together with their India data set third trimester data. And then we noticed certain problems where we have different clinical practice. Because some of the features that is measured in Malaysia are not measured in India, some of the features measured in India is not measured in Malaysia. So the same machine learning models is unable to apply for both countries. So what we do is we propose a domain generalized predictive SGA model framework, because we believe if this is happen between India and Malaysia, if we want to extend it to some other countries, perhaps the similar problems will arise as well. So what we do is how to mitigate this problem where there's a mismatch in features. We have this domain generalized prediction model where we have two data sets. So in Malaysia data set we have 18,000. The number of features we only have 15. In India we have much more smaller data sets, 1,760. But the features, the number of features we have is slightly more, 23. What we do is we have this feature imputations models module where we find the common features exist in both Malaysia and India, and we train the models to predict the missing features. So in this particular part, we will continue the iterations until we get a unified data sets. And in over here, you have to ensure that the machine learning models need to be accurate so that whatever the missing features that is imputed from the models do not create more noise for the downstream task, which is the SGA prediction models. After we finish that, then we use our independent testing data sets. We test and see what happened. So as you can see from here, this bar chart shows the results on the Malaysia cohort. These three bars shows the result for random forest. The orange bar shows the baseline where we use the Malaysia data to train and test on Malaysia data. So we can see the performance is quite high, around 0.79 or 0.8. And then the second, the green color bar, is we train on India data sets. Okay, we train on India data set, test on Malaysia data sets. Okay, and then you see that the performance drops significantly. I think this could be just due to the smaller data sets happen in the India data sets. When we use the unified data sets, the performance slightly lower than the orange color bar, but is still reasonable. And the same trends was observed in all the other models like logistic regression, support vector machine, and etc. Then we look into India cohorts. As for the baseline, using India datasets to train and test on India datasets, we have the performance around 0.6. And then if we use the Malaysia dataset to train, test on Malaysia data, it gets slightly higher. But when we use the unified datasets, then the performance is much more higher as compared to the orange color baseline. All right, so we see that the same trend happens for logistic regression as well, and also in the neural network. If we look at the overall performance, logistic regressions, the most simple models, it still works the best as compared to the complicated neural network. So that is about the first project that we are doing right now. The second project that I'm going to share with you all is the MIMOSA, which is the Mobile Mouth Screening Anywhere, which we collaborate with Cancer Research Malaysia, a digital health platform for early detection of oral cancer. So now I'm going to, so let's look at the video of launching.
My name is Professor Cheong, and I'm the head of digital health at Cancer Research Malaysia. I'm also the project lead for the MIMOSA project. MIMOSA is a mobile health app that enables us to connect remote villages to healthcare services and enables early detection of oral cancer.
Ya, memberi manfaat yang banyak lah kepada penduduk kami. Semenjak kami buat saringan dengan penduduk lah, dia boleh menjimatkan masa dan kos untuk mereka pergi pulang balik ke klinik yang berdekatan lah.
The Ministry of Health is key to the project because the images are reviewed by the dentist and the specialists within the Ministry of Health, and they will be the ones giving the referral decisions that will be communicated by the healthcare volunteers to these patients.
Jabatan Kesihatan Negeri Sarawak telah terlibat dengan projek MIMOSA sejak tahun 2022 lagi. Ketika pihak Cancer Research Malaysia membentangkan projek tersebut kepada pengarah Kesihatan Negeri Sarawak untuk menyatakan hasrat mereka menjalankan kajian lapangan perintis projek MIMOSA di Sarawak. Semenjak itu, pakar pergigian dan pegawai pergigian kami telah bekerjasama rapat dengan Cancer Research Malaysia dalam perancangan dan pelaksanaan projek ini di Sarawak.
So we are very thankful for our initial funders such as Ststistics Malaysia, and currently we are funded by the Ministry of Science, Technology and Innovation and also the German Embassy in Malaysia. We were also very grateful to the sponsors of Cancer Research Malaysia, including Yayasan Petronas and Yayasan Sain Dabi, without which we wouldn't be where we are today. MIMOSA changes the oral healthcare landscape significantly. From not being able to know whether an ulcer in your mouth is dangerous, to being able to connect to a specialist and get an appointment within 48 hours is really a paradigm shift. So MIMOSA does not only help with early detection of oral cancer, it empowers the community and the individuals within this community to take care and take charge of their oral health.
Pandangan saya memang diteruskanlah, memang bagus untuk masa depan. Terus selanjutnya, terus dijalankanlah dari masa ke masa.
Alright, so this project is actually collaborating with the Cancer Research Malaysia. They are the PI and I'm the computer scientist teams they are working with. And what they really started is they started as a telemedicine. They don't have any AI, so they do an apps and then they help the patients to arrange appointments to the clinics. Because in Malaysia, we have like East Malaysia and West Malaysia. East Malaysia, Sarawak, we have a lot of rural areas where the oral lesions or oral cancer's prevalence is much more higher. So the problem right now in Sarawak is that since they are in rural areas, and it is very difficult to travel from the clinics to the city. So a lot of the patients, actually they have oral lesion symptoms and they do not know. And then by the time they go to the clinics, it's already too late. So we wanted to have some AI where we use computer visions, whether we can detect the certain oral lesions that needs to refer to the specialist as soon as possible. And one of the criteria to have this deep learning model is that you cannot be too heavy, because in the rural area, the internet is really very poor. Some of the places really don't have any internet connectivity. And if you want to have a very heavy models that cannot connected to the cloud, then it's not feasible at all. So one of the criteria that we obtains from the Cancer Research Malaysia is that we have to able to do the inference, do the predictions offline, where the models need to be small and is able to put into the mobile phones. So we come up with this efficient B1 TGAM net, where we train using the backbone of the efficient B1 as a feature extractors, coupled together with the triple attentions, gem pooling, and head neck layers over here. The outcomes of the model is to really whether after take this photo, should we refer these patients to the clinics or do not need to refer. We can just still wait, not so important, not so urgent. And in these models, we compare with a few other models, one light models, one medium models, and two heavy models. If you can see from here, the F1 score that we obtains is the highest among all, around 0.882, and the efficiency is also better as compared to the others. We also did a subgroup analysis. As you can see from here, 0.88 is the overall performance F1 score. We do a subgroup analysis in terms of age to see whether there's any bias towards elderly or younger patients, less than 40, 40 to 69, and also above 70. So you can see that the performance is around the same. Similar for the gender as well, female and males, not much difference. And we also, in our data set, we have 5 countries data: India, Indonesia, Malaysia, Nepal, and also Sri Lanka. But surprisingly, you will notice that the other 4 countries, India, Indonesia, Nepal, and Sri Lanka, has slightly higher than the baseline 0.88. But Malaysia is significantly lower as compared to the other countries. So we further dig into see what happens. Because in Malaysia, we have 3 different ethnicity, Malays, Chinese, and also Indians. Something very interesting to look at is that you will notice that Indian data sets, have a slightly higher F1 score compared to the overall Malaysian performance. Chinese and Malay is slightly lower. So we suspect it could be due to the data sets. So because Indians in Malaysia, perhaps the skin color tones, all these may have an effects over here. So that's why they will have better performance, because we have more data sets that represented like in the dark color skin tone. And lastly, we also look into the subgroup for different clinical diagnoses, like cancer and OPMD are the most important and most serious that need urgent referral. And we're able to capture all 100% for cancer cases and around 85% for OPMD. And the next thing that I want to share with you all is about the transparency and also the reproducibility of the AI models. Since everybody, I think, can really do machine learning models quite easily, but how do we know whether the model is transparent and other people can reproduce your works, right? There are things inside every procedures that we have to explain very clearly. So that's why in order to enhance the quality and also transparent of the health research, there is this guideline tripod plus AI statements that we have to comply, where you have to state down the different criteria like what is your patient characteristics, are there any bias, if your data set is imbalanced, are you doing any balancings, and how this will affect your results. So all these things will make the research in AI, especially in medicines, more standardized and more comparable across the different publications. Then after paper published, then what, right? The most important thing is we hope that whatever that we have developed can really deploy into the clinics and really help patients. a lot of us actually will be involving in design and develop, and also the second phase, evaluate and validate. And the most difficult part is about clinical integrations, technical integrations into the clinics, and then we want to scale it out. So it is very important that if we want to do AI in medicines, we have to really collaborate with the doctors and the hospitals and really understand what is the clinical workflow. And then when we design the machine learning models or whatsoever, it has to really fit into the clinical workflow. Because the clinical workflow is something that is very difficult to change when they have already established for decades. And it follows certain guidelines and whatsoever. So that's the difficult part in current clinical healthcare, especially adopting AIs. But I believe people are actually really making efforts of moving that, and you will see that FDA medical device approved device for AI is also increasing. So people are actually shifting their mindset and getting more prepared for all of this. So to summarize, I believe AI will undoubtedly change how we work in healthcare. So whether or not we have to accept that AI will somehow change some things in the hospitals. And as a developer, especially like computer scientists or AI developers, we have to really be responsible and also be transparent when we develop the whole system or the whole workflow. Because whatever that we design eventually will be used, and if we are not designing transparently or responsibility, we may be really affecting people later on. Lastly, just to share, we have to be creative in designing the AI solutions, because sometimes using the standard procedure, it may not really help, because the data sets is different across regions, across country. So we really need some creativity when we design the solutions. Lastly, we just want to acknowledge my lab members, the students who helps to make all this work success, and also the grants who supports the projects for all doing this. Lastly, thank you very much everyone. So that's all from my talk. Okay, so since we are late, I think we can have the Q&A during lunch. Thank you.
Thank you very much, ma'am, for your insightful keynote address for ICDS 2025. And we invite you to please remain on stage. And we kindly invite to present the token of appreciation the Director for the Center for Data Science and the Head of the Department of Statistics, University of Colombo, Dr. Dilshan Tisera, on the stage. Thank you, madam. Moving forward with the HO saying that every good thing must come to an end, let me now invite the Co-Secretary of ICDS 2025, Dr. Deshan Vikramarchi, to propose the vote of thanks.
The head of the Department of Statistics, Dr. Dilshan Tisera, keynote speakers, Professor Hiroshi Mamitsuka, Dr. So Shirley, conference co-chairs, Dr. Gayan Dharmaratna and Dr. Kang Shong Fei, advisory committee members of ICDS 2025, board members of the Center for Data Science, staff of the Department of Statistics, fellow academics, all presenters, and distinguished guests. On behalf of the organizing committee of the 3rd International Conference in Data Science, ICDS 2025, it is my great privilege to deliver the vote of thanks at this inauguration ceremony. First and foremost, we extend our deepest gratitude to Professor Indika Mahesh Karunathiwika, the Vice Chancellor of University of Colombo, for his guidance and support in making this conference a reality. We are honored with his presence today and his inspiring words. Our sincere thanks also goes to the Dean of the Faculty of Science, Senior Professor Upul Sonnadara, for his continuous encouragement and support he has extended to us throughout the entire process. We are also thankful to the Registrar and Bursar of the University of Colombo, as well as Senior Assistant Registrar and Deputy Bursar of the Faculty of Science for the immense support throughout the process in handling administrative and financial matters. We are very much grateful to the head of the Department of Statistics, Dr. Dilshani Thisera, and the former head of the department, Dr. Rushana Begunawardana, for your continued guidance, leadership, and efforts towards making ICDS 2025 a success. A special word of appreciation is extended to our keynote speakers, Professor Hiroshi Mamitsuka and Dr. So Shirni, and the conference co-chair from University Malaya, Dr. Kang Sham Fei, for accepting our invitations and traveling all the way from Japan and Malaysia to join with us today. Your willingness to share your expertise has undoubtedly elevated the academic value of this conference. We are truly delighted to strengthen this academic collaboration, and thank you once again for making this event memorable. To all our presenting authors and participants, both local and international, thank you for your enthusiastic engagement and for choosing ICDS 2025 as a platform to share your research. Your contributions enrich this conference and strengthen our global data science community. Our special thanks also goes to all session chairs and moderators for facilitating the technical sessions. Our sincere appreciation goes to all members of the Board of Management of the Center for Data Science for your leadership, encouragement, and extensive support in making this event a success. We are also grateful. We gratefully acknowledge the Advisory Committee of ICDS 2025 for their guidance and support throughout. We also thank all reviewers for their dedication in evaluating submissions within the stipulated timelines and supporting a smooth review process. We also extend our sincere thanks to our sponsors, our knowledge partner, Octave John Keels Group, and our silver partner, Creative Software. Your generous support has been crucial in making ICDS 2025 possible. Our appreciation also goes to the resource persons of the conference workshops, Dr. Kang Sham Fei, Mr. Susara Auchitya, and Mr. Meranga Gamage, for dedicating your time and sharing your expertise with our participants. Moreover, we extend our thanks to the members of the STAT Circle for organizing the mini hackathon as part of this conference. We congratulate the Mini Hackathon 2025 winners, and we also appreciate the teams from University Malaya for joining with us at this competition. Our heartfelt thanks also goes to members of the IT unit and FOSS Media for developing the conference webpage and ensuring the smooth conduct of today's program. A special thank goes to Mr. Vinuptis Malpola and Mr. Shaka De Silva for comparing the event. We also take this opportunity to express our gratitude to the founding director of the Center for Data Science, Dr. Rasika Jayatilaka, and the head of the department at that time, Dr. Dilhari Artikala, for taking the initial steps that led to the establishment of the Center for Data Science. Finally, our deepest thanks goes to the organizing committee, academic and non-academic staff of the Department of Statistics, instructors, and student volunteers for your timeless effort behind these scenes. Your commitment and teamwork have been instrumental in bringing this event to life. Our special thanks also extends to Professor Lakmal Veeravarna for his generous support on multiple occasions when preparing for the conference. Finally, thank you to everyone gathered here today for your presence and participation. We look forward to 2 days of stimulating discussions, valuable networking, and meaningful collaborations. Thank you, and we wish you a successful and enriching conference ahead.
much, madam, for your words. Ladies and gentlemen, with that, we draw the curtains of the formal opening ceremony of International Conference of Data Science for the year 2025. Let us once again express our profound thanks to all our distinguished guests, keynote speakers, and the partners for gracing this occasion. Your presence and insightful contributions have set an inspiring tone for the days ahead.
We now officially conclude the inaugural session of the 3rd International Conference in Data Science. I am Tishaka De Silva.
Ms. Malpula, thank you for being a part of ICDS. Thank you and have a nice day.